Hello and welcome to my YouTube channel. In this video, I'm going to tell you about aromatic, anti-aromatic and non-aromatic. But before that, let me tell you about what is aromaticity. Okay, so the extra stability of cyclic conjugated compounds corresponding to their acyclic compound that is known as aromaticity. So the cyclic compound like these, they are more stable than their corresponding acyclic compound like these. So this one is more stable. So this is known as aromaticity. Now let's talk about conditions for aromaticity, like what is aromatic, anti-aromatic and non-aromatic. How will you identify between these three? So the aromatic compound, they are usually cyclic, and anti-aromatic compound, it is also cyclic. This is planar and this is also planar. Third thing is this is conjugated and this is also conjugated. Fourth thing is here sp3 carbon, it should be, it must be absent during conjugation, and same applies for here in the anti-aromatic. Here also sp3 carbon, it should be absent during conjugation. Now aromatic compound, these follow Huckel's rule. What is this Huckel's rule? They obey Huckel's rule, that is 4n plus 2 pi electrons should be there. This also follow Huckel's rule and it is like that 4n pi electrons should be there. Okay, so now let's talk about non-aromatic. What are these? If any compound that does not follow all of these five rules, then it will be non-aromatic. Either of these five rules is not followed by any compound, then it will be non-aromatic. If any compound, they does not obey any of these five rules from 1 to 5, then it will be non-aromatic. Okay, now let's talk about this Huckel's rule in brief. Now for Huckel's rule, and aromatic compounds, they follow 4n plus 2 pi electron rule and these follow 4n pi electron rule. Now let's talk about aromatic compounds first. So as you know, these follow 4n plus 2 pi electron rule. So how will you identify this? So for n is equal to 0, 4 into 0 plus 2 is equal to 2 pi electrons. So any compound having 2 pi electron and following all of these four conditions of the above, then it will be aromatic. Similarly, for n is equal to 1, there will be 6 pi electron. For n is equal to 2, there will be 10 pi electrons actually. Sorry. For n is equal to 3, there will be 14 pi electrons. So just like this, I hope you can calculate, through Huckel's rule which is aromatic and which is non-aromatic, following all the above four conditions. Now similarly for anti-aromatic, it follow 4n pi electrons rule. So how will you find the pi electrons over here? So for n is equal to 0, 4 into 0 is equal to 0. N is equal to 1, 4 into 1 is equal to 4 pi electrons. And for n is equal to 2, 4 into 2 is equal to 8 pi electrons. And similarly, you can identify this and above following the four conditions. If any compound is following four conditions and this Huckel rule, then it will be anti-aromatic. Now let's see some examples so you can easily identify them. Now let's take the example of benzene. You all are familiar with benzene, right? So let's see all the five conditions. Does it follow? So is it cyclic? Yes, it is cyclic. Is it planar? Yes, it is planar. Is it conjugated? Yes, it is conjugated. are sp3 carbon absent over here? So sp3 carbon are also absent over here, so this rule also follows. Now next comes the Huckel's rule. Let's talk about anti-aromatic, aromatic first. So for n plus 2 pi electron, so for n is equal to 1, you will have 6 pi electrons. So here are 6 pi electron present: 1, 2, 3, 4, 5, and 6. So this does follow all of the conditions, so it will be aromatic. Moving on to the next question, let's talk about this. Is it cyclic? Yes, it is cyclic. Is it planar? Yes, it is planar. Is it conjugated? Yes, it is conjugated. There are sp3 carbon absent. sp3 carbon are absent, but how many pi electrons are there? So here are 4 pi electrons. So it follows 4 pi 4n pi electron rule. So for n is equal to 1, it is 4 into 1, that is 4 pi electrons. So this follow the anti-aromatic rule of Huckel's rule. So it is anti-aromatic in nature. Okay, so now let's talk about our next example. Let's move on. Is it cyclic? Yes, it is. Is it planar? No, it is not. And you can see there are sp3 carbons also present over here. So this will be non-aromatic. Okay, so is it cyclic? Yes, it is cyclic. Is it planar? So that is like a confusion over here. Is it conjugated? Yes, it is conjugated. But there are sp3 carbon presence, sp3 carbon absent. So here we have a problem. So this is not present. So this will also be non-aromatic. Okay, now let's talk about this question. You can easily see there is sp3 carbon present, even though it is cyclic, but due to the presence of sp3 carbon, this will be non-aromatic in nature. Moving on to our sixth question, let's take the example of this. So will it be aromatic or non-aromatic? So you can see that there is a lone pair present. These lone pair will delocalize. These lone pair will delocalize, and it will be something like, sorry. So these lone pair, they will delocalize. Okay. They will delocalize. So because of this delocalization, and there will be 6 pi electron over here. It is cyclic. Yes. It is planar. Yes, and due to delocalization of pi electron, there will be 2 pi electron extra added along with these. So this follow 4n plus 2 pi electron rule. It is conjugated. Yes, there are no any sp3 carbon present, so this will be aromatic. Okay, so now let's talk about this question. So here also lone pair present, but they will not delocalize. They will not delocalize, and so this we will not count them. Not count them. Okay, so there are total 6 pi electron following 4n plus 2 pi electron Huckel's rule follow. They follow Huckel's rule. And is it cyclic? Yes. Is it planar? Yes. Is it conjugated? Yes. And are there sp3 carbon absent? sp3 carbon absent. So that will be also yes. So this one, it will be aromatic in nature. Okay, so now let's talk about next question. This here it is also lone pair present. and it is of delocalized type. This lone pair, it will delocalize, and there it is cyclic, it is planar, following 4n plus 2 rule, pi electron rule. It is conjugated also, and there are sp3 carbon is, are there sp3 any sp3 carbon present? So answer is no. So sp3 carbon absent. So this will be aromatic in nature. Okay, now moving on to our next question. There are two pi electron present. So we okay, as you can see, there are two pi electron. Two lone pairs present, in which only one will delocalize. Only one pair will delocalize. Okay, so is it cyclic? Yes, it is planar. Yes, and it also follow 4n plus 2 pi electron rule. As you can see, there are 6 pi electron, so it does follow that rule also. Is it conjugated? Yes. Are there any sp3 carbon present? No. So sp3 carbon absent. So this will also be aromatic in nature.